Hi guys, this is a video on mean absolute deviation, which may be something that you haven't seen before. So feel free to watch the video as many times as you need to and slow it down or speed it up depending on kind of where you are in your understanding. So first let's talk about mean absolute deviation. It's the measure that gives the average distance of each data value from the mean of the original set. So let's think about some of the words here. Mean means average, which we talked about previously. The absolute part of this refers to the absolute value. Um, when you take the distance from each data point to the mean, you take the absolute value because you want it to be a positive number all the time. And then deviation is another word for variation. It's how far apart they are. So the steps to find the mean absolute deviation: first, find the mean of the original data set. Second, you want to find the distance from each value to the mean. So to find the distance, you take the absolute value of the difference between the mean and each data point, and we'll look at that in a minute. And then we're going to average these distances. So first, we're just going to start off finding some mean absolute deviations. So the first step, again, is to find the mean. So the mean of 1, 3, 5, 14, and 17, you add them all together and divide by 5, and you're going to get 8. So, like I said, the mean of these data points is 8. Then you want to find the distance that each point is from the mean. So our mean is 8. Our first data point is 1. The difference is 7. Our second data point is 3. Our mean is still 8. The difference between those two numbers is 5. Then our third data point is 5. Our mean is still 8. The difference between those is 3. Our fourth data point is 14. Our mean is still 8. So that's a difference of 6. And then finally, our last data point is 17, and our mean is still 8. And so the difference there is 9. So those differences or distances we're going to add together and divide by 5. We're going to average those distances. When you add them up, you get 30 over 5. So 30 divided by 5 is 6. So our mean here is 8, and our mean absolute deviation is 6. When we look at our second data set, again, to find the mean, we take the sum of those numbers and divide by 5. We get 8 again. And then we want to find the mean absolute deviation. So again, we're going to take the absolute value of each difference or distance between the data point and the mean. So 8 minus 5, 8 is the mean, 5 is the first data point, is 3. 8 minus 6 is 2. 8 minus 8 is 0. 8 minus 9 is -1, but remember we're taking the absolute value. The absolute value of -1 is +1. And then the absolute value of 8 minus 12 is 4. So those are the distances, 3, 2, 0, 1, and 4. And again, we took the absolute value, which means the answer has to be positive. So when you total these distances, you get 10 divided by 5, which is 2. So our mean absolute deviation is 2. In our third data set, we have 5 8s. So when we find the mean of those numbers, it's still 8. But then when we look, the distance that any of these points are from the mean is 0. So 0, 0, 0, 0, 0. 0 divided by 5 is 0. So our mean absolute deviation is 0. So now that you know how to calculate the mean absolute deviation, let's look at why we calculate the mean absolute deviation. And so this is for interpretation. The closer the mean absolute deviation is to 0, the less variation there is in the data. Data values are clustered or grouped around the mean. So if we think about this, say we all did really, really well on an assignment because we really understood it. We talked about it for several days. Maybe you could use your notes. And everybody pretty much made around a 94. That's going to have a really small mean absolute deviation because they're all going to be pretty close together. Now say that maybe some of us didn't pay attention as well, or this was that week that everybody had the flu up and down. And so maybe we missed some classes. And say this time our scores were really spread out. This would mean that we would have a larger mean absolute deviation because the grades aren't necessarily all together. So what do you think about how outliers would affect the mean absolute deviation based on that? I'm going to give you just a second, or you can pause and think about it. So outliers are going to raise the mean absolute deviation. Having a high mean absolute deviation isn't necessarily a bad thing, but it can just mean that maybe your data isn't as concentrated as you would really like it to be. So we're going to work on some more examples. If you are really getting this, you don't need to watch the whole video. But if you are confused about something, then I would stick with it. Also, at any point in time, feel free to pause the video and work them out ahead to see if you can, to figure out how things are going for you. So number one, the speed in miles per hour of Will's last 6 pitches. So again, we find the mean first. We do that by taking the sum of our data points and dividing by the number we have. So to get our mean, we're going to get 450 divided by 6, which is 75. So then we want to go back and do 75 minus each of these numbers and take the absolute value. So the absolute value of 75 minus 71 is 4. And then the difference between 78 and 75 is 3. 0, 74, 80, and 72. So when we total those numbers, we get 16 divided by 6. 16 divided by 6 is 2.7. Then we have Nora's science grades. Again, we want to find the mean first. So that's 672 divided by 8, which is 84. And then we want to find the difference between each of those data points and 84. So when we do that, we're going to get 16, 32, 4, 12, 6, 10, 2, and 10 divided by 8. So that's 92 divided by 8, which is 11.5. Number 3, the weight in ounces of packages on a mail truck are 5, 24, 15, 35, 9, and 14. So here we want to find the mean first. So again, we take the sum of all of those weights and divide it by the total number. So we get 102 divided by 6, which is 17. Here, the mean absolute deviation, 17 minus 5 is 12. 24 minus 17 is 7. 15 minus 17, again, absolute value is 2. 35 minus 17 is 18. 9 divided by 17 is negative 8, but again, the absolute value. And then 17 minus 14 is 3. You sum all of those numbers, all those distances, and divide, and you get 50 divided by 6, which is 8.3. Number 4, the number of push-ups completed in 1 minute by a group of students. 4, 7, 10, 22, 25, 26, 32, 37, 42, and 45. You find the mean of those data points, which is is 25 push-ups. Then you find the difference between 25 and each of your data point values. Again, use the absolute value, so it's always positive. And you get 21 plus 18 plus 15 plus 3 plus 0 plus 1 plus 7 plus 12 plus 17 plus 20, which is 114 divided by 10, which is 11.4. The ages of the players on a hockey team. Again, first step, find the mean, which is 312 divided by 12. So the mean is 26. Then you take the difference between 26 at each of your data points and add those numbers together and divide by 12. And you get 54 divided by 12, which is 4.5. So bowling scores in the last round of a tournament. First step, find the mean. The mean is 1,050 divided by 12, so 87.5. Find the difference between 87.5 and all of your data points. It's kind of annoying that they're all decimals, but this does happen. It's very typical. When you find the sum there, you get 88 divided by 12, so your mean absolute deviation is 7.3. Birth weight in pounds of babies born on the same day at a hospital. First step, find the mean. The average baby weight is 7 pounds 2 ounces, or 7.2 pounds, I guess. Then you find the difference between 7.2 pounds and all of the recorded baby weights. And so you get 8.2 divided by 8. And this is a decimal, but we're going to round to the nearest tenths place. So we get 1.0 for our mean absolute deviation. And then number 8, the price of 6 packages of cookies are listed. First, we find the mean, which is $20.34 divided by 6, which is $3.39. Then we find the difference, or excuse me, the absolute value of the difference between $3.39 and each of the packages of cookies. And so when you do that, you get 3 divided by 6, which is 1/2 or 5/10. So which do you think is a better measure of the variation of data, range or mean absolute deviation? And explain. So I would like you to pause or take a minute and think about this before we continue. Your answer does not have to be exactly like my answer. The decision is probably needs to be the same, but the explanation can be different. So again, this doesn't have to be word for word. But my sample answer is the mean absolute deviation is a better measure of variation since it takes into account all the values and their distance from the mean. The range only uses the highest and the lowest values, ignoring how the other points may be grouped. So outliers could really affect the range more than they could affect the mean absolute deviation, and things like that. So anyway, let us know if you have any questions. I hope you guys are having a great day. Bye.